Hello everyone, welcome to the learning journey on MPLS and segment routing basic to advanced. This is our fourth session in this series and we are still exploring MPLS and different applications of it. In today's session, what basically we will look at first thing is MPLS VPN quick introduction. As I told you in our first session itself, MPLS was not popular because the label forwarding was faster. MPLS got so much popularity because of its application, and MPLS VPN is one of them. And today we will be looking at L3 VPN, and specifically we will look at a packet walk in the MPLS VPN. We will go really deep, exactly looking at how does a packet travel via an MPLS VPN layer 3 network. I will first show you via some animation how does the control plane is built up, how does the data plane follow that path, and then we will look at some actual packet walk, of course via some animations, and then I will also show you some show commands to validate whatever we had seen in the first three steps of this packet journey. Just a quick introduction about this series. This is actually a part of our live course. So today's session is just an abstract from that. I will put more details into the description. With that, let's just start with MPLS VPN quick introduction. And I want to start this with basically an analogy. And if I may ask you, what is the most beautiful sound in the world? It is basically somebody's name. So when I heard about this story that a person's name is the most beautiful sound in the world, I remember an incident when I was in ninth grade. And in the school in which I was studying, there were basically six students with the same name Sunil. And what was happening is whenever somebody called us, it was always a matter of concern for all of us because when somebody called, even our teacher or friends, we didn't know which Sunil they are referring. And sometimes we even used to laugh at this. So when I hear that the name is the most beautiful sound, it was actually not that true for me when I was in the ninth grade. So at that time, our teacher came up with a simple solution for this. They said that whenever we call these six students because they have the same name, let's call them by their full name. For example, it was Sunil Pareek for me, Sunil Kumar for my friend, and then Sunil something for the other students in the class. And I remember after that date, there was never a confusion. Everybody either used to call us by our second name because that was unique, or they used to call us by our full name. Basically, our name was added with something to make it unique. But why, in the first place, I'm telling you this analogy? Because I encountered the similar situation when I came to the corporate world for a job. My first job as an L1 engineer, I still remember where I need to provision some VPN based customer for a service provider. Of course, I was provided with all the resources. I was given a simple template in which I need to populate some variables and then push that configuration on the devices, and I was also equipped with some of the show commands to validate whatever I have done is working fine. If there is any issue, of course I need to report it. So on one fine day during the initial month of my job, what I saw that when I was provisioning a VPN, let's call that VPN as red VPN. So I did this configuration. I verified that the IP addresses which were here, let's say 10.10.10.1/24 subnet was this side, 10.10.11. Something subnet was this side, and 12.0 was this side. All of them were exchanging these route information fine. So I was good and I moved on to the next provisioning, which was a blue VRF. And during the validation, I saw that even this customer was also using the same series of IP addresses. And during my training, it was told to me that in networking there should not be an IP address conflict. But here there were two customers I provisioned, both were using the same address space. So with my limited knowledge around MPLS VPN at that time, I reached out to my mentor and the seniors, and what they explained is that Sunil, when these route come here, right, even in this space they are unique because you have associated them with red and blue. But when they come here, we actually put some tag in front of them to make them unique. It is basically some surname that we put in front of them, or maybe add that surname to this to make it unique. In technical terms, it was the RD value that my senior was referring at that time. But this reminded me the story which I just told you from my ninth grade. And our teacher had given this simple solution which worked seamlessly, and I was able to relate that and easily got this why we were adding this additional surname or prefix to this route so that we can make it unique. So I got the clarification and basically understood how does it work. And then if we look at this route, I have my /32 bit of IP address, let's say, plus this RD value, which is your 64 bit. That means if you are adding this, your route become bigger now. It is no longer a IPv4 address. It has become something else. So how does basically this bigger route is carried from here till this PE4? We will talk about that, but this analogy, this concept of RD, to add some prefixes in front of a route to make it unique, is for the beginner level audience. If you are experienced one, feel free to fast forward this and some more upcoming slides. I hope during the packet walk you may find something which can refresh your knowledge basically. But if you are a beginner, stay tuned. So as I was saying that now from PE1, I need to carry this route but along with this prefix. That means this complete route. This is no longer a IPv4 route. So what we basically call it is a VPN v4 route. What does it have? It have the 64-bit field of RD. Why? Because I need this prefix to make the route unique. And then 32-bit IPv4 is my actual address. So total 96-bit. But how do I carry this from PE1 to PE4? What protocol I will use? So for that, actually one of the existing protocol, which is BGP, was enhanced to MPBGP. And this MPBGP, these newly introduced extensions into the existing protocol helped the providers to carry this long prefix from one PE to other PE. But advertising this route, was it enough to communicate the two CEs? Basically, if I go back in our example, if I just carry this 96-bit route from here to here, will E will be able to talk to A? The answer to that is no, because in the data plane we are using MPLS, and MPLS, the fundamental principle which I have told you is that we need labels to forward the packet. I have carried this 96-bit route, but when the actual packet come, they will come in the data plane. And then I have this MPLS sitting at the door. He will check where is your label. That means I not only need MPBGP to carry this route, I also need the same protocol help to carry the label also, right? So that when the packet come in the data plane, it has the required label. So advertising just VPN v4 route via BGP is not enough to forward the traffic. It also need to have the label as well along with this route, so that the remote node can attach that label on that packet so that in the data plane it can be forwarded correctly. I will show you this packet walk in detail. So if this is something that is not making much sense as of now, stay tuned to this session and I will make sure that when you exit out of this session, you understand this aspect. But before that, let's just have a quick look at MPBGP. What I mean by MPBGP, right? So as I was saying, these multi-protocol extensions were added in BGP to fulfill these different requirements. For example, to make a route unique, I added some prefix, that RD value, but now I need to carry that route via some protocol. So there is this address family, which is your VPN v4 address family, This support was added to BGP. Likewise, there is VPN v6, there is L2 VPN, EVPN, there is MVPN. The list just goes on. It's the same protocol, BGP, and multiple such extensions were added to fulfill different requirements. And this is what I said to my fellow network engineers also. In the last decade, there has been so many innovations that has happened in the field of networking. But BGP had survived through all these innovations. It is still relevant, and mastering BGP is what I highly recommend. So now coming back to this, all these extensions, they are basically some capabilities that BGP advertise. So let's say if we are making a peering between BGP A and B, these are two devices, and there is some BGP peering, this will advertise certain capabilities. This guy will also advertise certain capabilities, and whatever they have in common, that will get negotiated, and rest will not function. So it's not like if there is some capability mismatch, your BGP session will not come up. So now let's just go back to our same topology and see how does the communication work from A to E. So this is a part of Red VPN, and I have provisioned it. So now I will take you through how does the control plane is built up, how the labels are distributed, and then how does it actually work in the data plane. And I also have some show commands to show that, as I was saying earlier. So let's just start from E. And here, let's say I have this subnet, right, that I want to ping or initiate some connectivity from A side. So for the users who is sitting here, if he want to connect to this subnet, let's say there is some server here in this subnet, then he basically need to have this route first of all here. So let's just see how does that work via control plane. So E being a CE router advertise this prefix 10.10.10.0/24 via some protocol on this link to PE4. This can be any PE to CE protocol. Once I learn that route on PE4, because this is VRF, and I know I haven't covered the VRF aspect, but if you guys have any question around this, feel free to leave some comment and I will be happy to provide some more details, or maybe the next video also. So this VRF will receive this route, but now from PE4 we need to send that route to PE1. So the first thing, it will add that prefix and make this as 96-bit route. Now this route via MPBGP we need to carry to PE1. Of course it will go via this RR because it does not change any of the fundamental principle of the BGP. That works the same way. You need a RR when this is IBGP. right? To avoid those full mesh for obvious reasons, basically. So this 10.10.10.0 with this RD is reaching PE1. But remember, in this domain, in the data plane, we have MPLS. So when PE4 send this route, it also need to send a label with it. Let's say this give a label 34. So PE1 will receive this route. PE1 will also receive this label that is allocated for this prefix by PE4. So PE1 knows that if this need to send any packet, if it send with 34 as label, PE4 will identify that this is for this prefix because PE4 only allocated that label. And here I want to tell you one more fundamental, that your route will go and then your packet will come or your traffic will come. They walk in opposite direction. So I had sent this route along with this label. So PE1 have this label 34, which is basically the out label. Remember this is out label 34 for this prefix. And then here also it will have some sort of CE to P protocol. There is no MPLS on this red link. So PE1 will only send this 10.10.10.0 route towards A. So A send some traffic now. Now our data plane, control plane route has reached to A. For the data plane, A will send some payload, some data packet. Because it is getting the route via PE1, it will send that packet to PE1. Now for PE1, because the domain on this side is MPLS, it cannot forward IP based packet. It has to be a labeled packet. So the packet that is coming destined to 10.10.10.1, let's say this server IP address is .1, PE1 will push the label because MPLS mandates that. What label it will push? It will push the label 34 on that packet. So what it will do? It will take that data packet which is coming from A and it will put that label 34. But now here is the problem. This label 34 is allocated by PE4. So only PE4 will understand it. But in between I have these nodes P1 and P2. So my job here is that I need to send this packet to somehow to PE4 with this label. Then PE4 will forward it further. But to do that, first packet should reach PE4. How it will reach PE4? For that, I need to use another label which is for PE4 itself. And that label is your transport label, which is allocated by LDP. So PE4 will have some loopback, let's say 4.4.4. This loopback is advertised in IGP, and then there is some label that is associated by each of these nodes. Remember, in our previous session, I have told you that LTP allocate label to all IGP based destination. That means 4.4.4.4, P2 will assign a label, P1 will assign a label. And when P1 assign a label, it will give that to PE1 because PE1 is directly connected. So PE1 with 34 will push another label which P1 had given for 4.4.4. It will put that label. Let's say that label value is 50. So packet come at P1 with label 50. Let's say this guy P2 has advertised some other label. So here a label swap will happen. On what? On this top label only. This label will not be touched. So this top label will be swapped with the label that is allocated by P2 for 4.4.4. After that, the packet will be sent in this direction. And if you guys recall, because PE4 is directly connected to P2, this label will be implicit null. That means the top label, this transport label will be taken off and packet will reach to PE4 only with label 34. And who had allocated this label 34? This is PE4 itself. So PE4 knows for what destination it had allocated that label, and it will simply forward it towards the correct destination. So that is how your control plane and data plane works. If this is something that had made some sense for you, let's just look at the actual packet walk. On the same scenario, for the same subnet, to E only with some animation, and then I will also show you some show command that should further strengthen your understanding of what I had explained so far. So here we will look at a packet journey from A to E. So this will be our source, this will be our destination, as I was showing you in our previous slide. So let's say that there is this packet that start from A, some payload basically, with a source address of IPE and destination address of IPE. Of course, it will put some MAC based header because this is Ethernet. And in Ethernet, if we want to forward the packet, we need these MAC, source MAC and destination MAC to forward the packet because that is what your Ethernet understand. So obviously my source MAC address will be MAC of A. What will be my destination MAC address? Based on the previous analogy, feel free to pause this video and guess. I hope you did that. The destination MAC address will be PE1 MAC address. So with that, the packet start from A and it will reach on PE1. When the packet reaches on PE1, because the MAC address in the destination belong to PE1, PE1 will process it. So PE1 will see that the source is IPA, the destination is IPE. It's a VPN customer, and because in the domain PE1 to PE4, the path is MPLS enabled, So it will put the label, the VPN v4 label, which was allocated by the node which is connected to E, that is the egress PE. And in our previous example, this was label 34 that I had shown you. But then I need to send the packet to PE4. So for that, I will put a transport label that will be allocated by LDP. I need to have this transport label that will be allocated by LDP in our case. So now our packet is good to send. But one more thing, as I told you, this is Ethernet. All our link between PE1 to PE4, they are all Ethernet. So here also I will need the MAC address for the packet to be forwarded on the wire. So the source MAC address will be MAC of PE1. What will be the destination MAC address? Basically the next hop. That's how your forwarding works in Ethernet. So you will have the MAC of P1, which is the next hop in the path. And if you recall from our previous sessions, MPLS stays between L3 and L2. Right? So with this, the packet comes to P1. P1 will not even touch the inner packet like PE1. P1 will also not look at the VPN v4 label. P1 will only look at this top label, which is transport label, swap it with other label and forward that. To forward, because Ethernet, we need to have the MAC address. The packet will come to P2. P2 is directly connected to PE4, and PE4 is the egress PE device which is connected to my customer edge device, which is E. So P2 will also not look at the inner packet. P2 will also not look at the VPN label because it has nothing to do with it, but it will look at that transport label. Because P2 is directly connected to P4, this transport label will get popped because of implicit null operation, and then you put the MAC address of P2 and the destination MAC address will be finally your PE4. So this will be the packet, and now when the packet is ready to reach PE4, look at this. There is only one label on the packet, and who had allocated this label? It is PE4 only. So when the packet come at PE4, because this label is allocated by PE4, PE4 will know that this packet need to be forwarded to E. So it will send that packet out via that link which is connected between PE4 and E. And there is no MPLS here. That means this is an IP packet that you see here. Right. So I hope this is clear. Now let's just look at some of the show command also. So these are some of the show command from my lab. So here, if I do show IP BGP VPN v4 RD and then that particular prefix, remember this was the prefix for E, and I am executing this command on PU1. So I'm getting this route via PE4 as you see dot 4 here, and then apart from all these normal BGP attributes, you see this. This is the out label that PE1 should use to send the packet. This label is allocated by PE4. PE4 send this via BGP when it is sending this route update. And then SF command if I do again on PE1 only. So this is that label 34. This is that label 34 that PE1 will push. This label will be only understood by PE4. So I need to have another transport label also, which is label 16, to take this packet, of course hop by hop, with some swap operations till PE4, and then PE4 will forward it. So let's just look at the entry for PE4 also. So this is the command that is executed on PE4. If I look at the label forwarding for 34, outgoing is no label, because this is the egress PE. After that, it is the customer network, and this is a VPN label. PE4 will simply forward it via this interface, which is connected to E, which is your customer end device. So that is how you deliver the packet from A to E. So with that, let's just wrap this module here. I hope the information that was provided was useful, and thanks a lot for viewing.